Okay. 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 The paper called. I'm audible. Hello. Hello.
Yes, sir.
Okay, fine. So the paper called Organic Synthesis. Okay, it's CH302 OC is the paper code, and the name of the paper is Organic Synthesis. So under that, the unit called reagents. So under that, I am taking Ra-Ni nickel and PPA. PPA means polyphosphoric acid for today's class. Okay, first let's look into the what is Ra-Ni nickel. And before that, you should aware about what is reagent. I think you are aware about the uh, uh, in a reaction, there will be a reactant, product, a reagent. Okay, reactant may be converted into a product. A reagent may be the responsible for the conversion of a reactant to the product. So here I am taking Ra-Ni nickel. Ra-Ni nickel is a catalyst. Okay, Ra-Ni nickel is a catalyst. It is responsible for the conversion of substrate into a product. So let's look into the what are the substrate and what are the products, and how the reagent, more particularly Ra-Ni nickel, is responsible in the transformations. Okay, and now okay, no, right. I will go to the next slide. So here you can observe that Ra-Ni nickel. So Ra-Ni nickel, how one can prepare? It is prepared starting with an alloy. Okay, it's called a Ra-Ni nickel alloy. Ra-Ni nickel alloy is nothing but a aluminum, a nickel, and then sodium hydroxide combination is called Ra-Ni halide. How it is obtained? When it is treated with water, so this aluminum will going out as a sodium aluminate. Okay, and here what you need to remember, sodium aluminate is a soluble in water and it will go out. So whereas uh, NiH is insoluble. NiH is insoluble. NiH is insoluble. It is a gray color compound, and it can be filtered. Okay, it can be filtered, washed with water, and then stored with ethanol. Okay, alcohol free means water moisture free. Okay, and this should not be exposed to atmosphere because it will catches fire. Catches fire means it can absorb the moisture present in the atmosphere and it can catch fire. So that is the reason airtight bottle is required. And okay, of course, one can store in the atmosphere of nitrogen also. It is important to note that the surface, so whatever nickel surface is there, in that hydrogen is adsorbed. If the more quantity of hydrogen is adsorbed on the nickel surface, the reactivity of the catalyst is more. And if we are looking into the types, W1 Ra-Ni nickel is there, W2, W3, W3, W4, W6, W7 also are there. Here W stands for vincosin. And one more, Ra-Ni nickel is hydrogenating catalyst. Okay, hydrogenating. That means it will add hydrogen to the substrate. We will look into the what are the substrate. And this particular reaction, it is more effective at 150 to 200 degree temperature. That means it is effective at high temperature. Right. And then Ra-Ni nickel catalysts are alkaline in nature. So why it is alkaline? Because it is prepared from sodium hydroxide combination. No? That is the reason it's alkaline in nature. And what it means, if the substrates are the acidic in nature, then Ra-Ni nickel catalyst itself, it deactivates. So that is the demerits you need to remember. That means Ra-Ni nickel is alkaline in nature. If we are using a substrate as a acid, then Ra-Ni nickel itself deactivates. And reaction you won't expect. This is about little information about Ra-Ni nickel. So sometimes they used to mention as RANI, or RE. Okay, RENI means Ra-Ni nickel. NiH means it's also a Ra-Ni nickel. Sometimes people used to mention that Ni-H2, that's also a Ra-Ni nickel only. So, this particular reagent is discovered by a scientist called Murray Ra-Ni, and is discovered for the purpose of hydrogenation of vegetable oils. This is about a little information about Ra-Ni nickel. So with this, I will go for a application, how the Ra-Ni nickel is useful in organic synthesis. Okay. So I think you are aware about this. This is a double bond. What is double bond? Double bond means alkene. Alkene means unsaturated compounds. Okay, unsaturated compound. Unsaturated. So what hydrogen in presence of Ra-Ni nickel? Hydrogen will be added to double bond. So double bond is converted into single bond. So you are converting an unsaturated compound into saturated compounds. So for that, what is happening here? Hydrogen will add it to double bond. Hydrogenation. Catalytic hydrogenation. Here catalyst, what is catalyst? Ra-Ni nickel is the catalyst. So this is the one is obtained. Suppose ethene you are taking and the obtained one is ethane. If you are taking 1,4 butadiene, what will happen? So initially one of the double bond, this double bond and this double bond can be reduced by the consumption of 1 mole of hydrogen. Otherwise, what will happen? Hydrogen can add to here, this double bond can go over here, and this can pick up one more part of the hydrogen. So what it means? So it is possible to get a mixture of partially saturated compounds. Suppose if we are treating again, these two are treating with one more equivalent of hydrogen in presence of Ra-Ni nickel, this particular double bond also reduced and this also reduced. Then we will get a compound like this. So overall, what you need to remember, alkenes are readily hydrogenated. Hydrogenated means hydrogen is added to alkene in the presence of Ra-Ni nickel catalyst, and more particularly at room temperature. Room temperature means 25 to 30 degree temperature in Bangalore. Then with this, I will take up one more application. I think you are aware about the aromatic compounds. So here I am taking a naphthalene. Okay. So what is difficulty in this? So usually if we are hydrogenating with other catalytic condition other than nickel, what will happen? You may end up with partially saturated compounds, tetraline. Tetraline is the partially saturated one. That means one of the ring will be reduced. So remaining other ring intact. So that's what usually the hydrogenated product, if we are using a other catalytic agents. But with Ra-Ni nickel at low temperature, these two double bonds are reduced. Then it's called tetraline. But Ra-Ni nickel at high temperature in the sense maybe a 150 to 200 degree centigrade. So that time this particular three double bonds also reduced, and the obtained one is called decaline. So overall, what you need to remember, usually aromatic compounds partially hydrolyzed in presence of other catalytic agents, but in presence of nickel at low temperature, a partially saturated one is the product, is called tetraline. At high temperature, completely saturated one, completely hydrogenated one. That means naphthalene is converted into decaline. Okay, again, here I am not mentioned about the stereochemistry. If this ring junction is trans, then it's called a trans ring junction. If this ring junction is cis, then it's called a cis decaline. I think you are aware about the stereochemistry of decalines. So with this, I will go to the next slide. So next I am taking the reduction of phenols. I think you are aware hydroxy. If the hydroxy group is directly attached to the phenol, benzene, it's called phenol. If this phenol is subjected to catalytic hydrogenation in presence of Ra-Ni nickel, so you will get cyclohexanol as the product. What it means? It means that all the three double bond present in the benzene ring is hydrogenated, so giving rise to cyclohexanol. Sometimes phenol or resorcinol or whatever it is. So sometimes they also undergo partially saturated one. So look here. So cyclohexanol is a partially saturated one. So what it means? Phenol consumes 2 moles of hydrogen, giving rise to cyclohexenol, enol, a double bond and OL. I think you are aware about the enol. So keto-enol tautomerism. That means the bond between the oxygen and hydrogen will come over here, and this can pick up proton. So it's called keto-enol tautomerism. So similarly, in this case, resarsenal. So in the resarsenal also, when it is treated with hydrogenation in presence of Ra-Ni nickel, this particular double bond is reduced and forming a cyclohexadiene. Diene means two double bond. Diol means two alcohol. This we can also call it as a dehydroresorcinol. So this enol, okay, undergoes keto-enol tautomerism. That means the bond between the oxygen and hydrogen will come over here. This will pick up proton. The bond between the oxygen and hydrogen will come over here, and this will pick up proton, giving rise to cyclohexadione. Cyclohexadione is the product. So this is about what will happen when a Ra-Ni nickel is treated with phenols. Okay, so that means phenol undergoes hydrogenation in presence of Ra-Ni nickel, gives cyclohexanol as the product. And if it is a partially hydrolyzed, partially hydrogenated, in such cases, if there is a product undergoes keto-enol tautomerism, it can give up ketones as the product. So this is about what will happen when a phenol is subjected to hydrogenation in presence of catalyst. Now I will take two more kind. So that is Ra-Ni nickel reduces nitro group. So I think you are aware about NO2 functional group is called nitro group. So this nitro group is reduced. How it is reduced? Hydrogen will add it to nitro group. Okay, maybe what you can do, you can also write the mechanism for the conversion of NO2 to NH2. So that means Ra-Ni nickel, it's only a catalyst, but it contains hydrogen. That hydrogen will add it to NO2 group. How it will add? H minus can add to N, and C double bond O converted into OH. When it is added one more H, OH will go out as a water. So these two will go out as a water, and H will add to nitrogen. So that is how NO2 is converted into amine. And similarly, so C triple bond N is called the nitrile. So nitrile undergoes hydrogenation. So H2 stands for hydrogenation in presence of Ra-Ni nickel. So what is the role of H2? H2 will add, one H will add to this carbon, another H will add to this nitrogen. So similarly, one more H, two equivalent of hydrogen is required to convert a nitrile into amine, more particularly primary amine. Similarly, this is called oxide. C double bond NOH is called oxide. So here also addition of hydrogen. How the addition of hydrogen? One H will add to this double bond, and this bond pair can pick up one more H. And later on, this OH will go out as a water, giving rise to a primary amine. What it means? So it means that nitrile means this compound. Nitrile and oxides undergo catalytic hydrogenation in presence of Ra-Ni nickel, gives primary amine as the product. So with this, I will go to the next slide. So reduction of halides. What will happen? A halogen containing compounds on reaction with Ra-Ni nickel, okay, on reaction with hydrogen in presence of Ra-Ni nickel. So Ra-Ni nickel is the one is the responsible for the conversion of haloharine to hydrocarbon. So that means it replaces chlorine with hydrogen. So dehalogenation occurs. Okay, when a haloarine treated with hydrogen in presence of Ra-Ni nickel, this Cl is replaced with H. So that is how a product hydrocarbon is obtained, and this is halogenated hydrocarbon. Similarly, tosylate. Tosylate means OSO2 benzene CH3 group is called tosylate. What you need to remember, OSO2 group is called tosylate group. So maybe a methyl tosylate, or maybe a ethyl tosylate, or maybe a para-toluene. This is called para-toluene tosylate. So overall, this tosylate, okay, is replaced with hydrogen. What it means? It means that oxygen attached to the benzene ring can be replaced with hydrogen in presence of catalyst. Similarly, halogen, which is attached to the benzene ring, can be replaced with hydrogen in presence of Ra-Ni nickel. So that's what you need to remember. So what it means, halogen can be replaced with hydrogen in presence of catalyst, and then tosylate group can be replaced with hydrogen in presence of catalyst. This is about what is called as application of Ra-Ni nickel in organic synthesis of esters, hydrocarbons, amines, okay, and saturated compounds and cyclohexanol, okay, many more. So I will also take up one more compound, reduction of carbonyl compounds. So this is I think you are aware about this is aldehyde, this is ketone, and this one is unsaturated aldehyde. So what will happen? So hydrogen is added to aldehyde. So you know that when hydrogen is added to aldehyde, it will give you alcohol. Similarly, when hydrogen is added to ketone, it will give you alcohol, more particularly secondary alcohol. This is primary alcohol. And here it's an interesting, you can observe that alpha beta unsaturated aldehyde. So that means this double bond is also reduced when it is treated with hydrogen in presence of Ra-Ni nickel, and aldehyde group also is reduced to primary alcohol in presence of hydrogen in presence of Ra-Ni nickel. This is again the role of Ra-Ni nickel in the preparation of alcohol, starting with carbonyl compounds. And here I am taking a ketone, okay, more particularly a amino substituted ketone. And here, what is the thing you need to remember? This is called reductive amination. So what is reductive amination? Reductive means reduction. So reduction means addition of hydrogen. And you know that amination, amine is added. So it is very simple. You just look into that. This is a ketone. A ketone, when it is treated with ammonia, it gives skip base. What is skip base? C double bond NH is called skip base. C double bond NH, when it is treated with hydrogen, a double bond C double bond N is converted into C single bond N. So that is conversion of a ketone to a primary amine with the hydrogenation in presence of ammonia, more particularly in presence of nickel, is called reductive amination. And here the skip base is the intermediate octet, and the skip base is called C double bond NH. C double bond NH is reduced when it is treated with hydrogen. So this is about the reductive amination. So with this, I will go to the next slide. So next slide is about desulfurization. That means removal of sulfur. I think you are aware about sulfur compounds, okay, sulfur containing compounds. So tetrahydrothiophene is the name of this compound. This sulfur can be removed. How it is removed? This is going out as a nickel sulfide. Nickel sulfide is the byproduct. So in place of sulfur, there will be a hydrogen bond formation. Here one H, here one H. That means hydrogen is added to these two carbon atoms. Sulfur will go out as a nickel sulfide. So overall, this compound is called sulfide. Suppose if there is a compound disulfide linkage means S and S bond formation, and such compounds are called disulfides. So what it means? Sulfides, okay, undergoes desulfurization. Similarly, disulfides also undergoes desulfurization, giving rise to hydrocarbons. That's what you need to remember. When a sulfides or disulfide is treated with hydrogenation in presence of catalyst. Okay, here one small thing you need to remember. This is not required. Okay, what is not required? This NH3 is not required. This you can erase it. Okay, you need to remember that Ra-Ni nickel is the catalyst, is required for the desulfurization of sulfides and also desulfurization of disulfides. And what are the products obtained? Hydrocarbons are the product, and sulfide will go out as a nickel sulfide. So look here, this is a thioester. Instead of sulfur, if it is a oxygen, it's called ester. If there is a sulfur, it's called thiosulfur, thioester. So what will happen? So when thioester is treated with hydrogen in presence of catalyst, so there will be a breakage here. Hydrogen will add to this carbon and one more hydrogen will add to this sulfur. Of course, later on that SH can react with nickel, giving rise to nickel sulfide and ethane. Okay, CH3, CH2 and H. Ethane will be going out as a byproduct. And we will also discuss about the application of dithiene. Okay, here I am talking about 1,2-dithiene, but as per the syllabus, we need to discuss about 1,3-dithiene and its application in organic synthesis. That we will discuss later. But at this moment, what you can do, remember, this is a ketone. Ketone can be protected. How the protection? By forming thiol. So this is a thiol. Okay, means the lone pair present on this sulfur can react here. C double bond O can be converted into COH, and again that lone pair can react here, and removal of H and OH going out water as a byproduct. This reaction occurs in presence of Lewis acid called trifluoroborane. So the obtained one is called 1,2-dithiene. So this 1,2-dithiene on reduction, more particularly hydrogenation with hydrogen in presence of nickel catalyst, there will be a regeneration of dithiol, and also what you can observe, propane is the product. So what you started? You started with acetone, and what is the product obtained? Propane, a hydrocarbon. What it means? So by the application of Ra-Ni nickel, one can convert a ketone into hydrocarbon. That's what you need to remember. So up to this, we discussed about what is Ra-Ni nickel and how it is useful in the preparation of saturated hydrocarbons. That means alkene can be converted into alkanes, and nitro group can be converted into amino compounds, and aromatic compound can be converted into aliphatic compounds. More particularly, naphthalene is converted into decalene, and phenol is converted into cyclohexanol. And what is that? Here I think you are aware about a halogen is converted into hydrocarbon, and tosylate is converted into hydrocarbon, and carbonyl compounds is converted into alcohols, and reductive amination. So that means simultaneous formation of skip base, and the obtained skip base was reduced to get a primary alcohol. This particular reductive amination is very much useful in the preparation of amino acids, more particularly alpha amino acids. I think you are aware about alpha amino acid. Alpha amino acids are the naturally occurring compounds. They play a vital role in enzymes, biocatalysts, and also antibodies. And I think in your second semester you learned about amino acids. So then, and one more application, it's desulfurization of sulfides and desulfurization of disulfides. Okay, this is about Ra-Ni nickel. Now tell me, is there any doubt in Ra-Ni nickel? So because I want to move to the another reagent called polyphosphoric acid. Do you any doubt up to this?
No, sir.
Okay.
No, sir.
Okay, I will go to the next reagent called polyphosphoric acid. Okay, it's also called as PPA. So phosphoric acid, this what you can observe that P means phosphorus, P double bond O minus OH OH. What it means? H3PO4 is the phosphoric acid. H3PO4 phosphoric acid, when it is treated with the phosphorus pentoxide P2O5. So what is the role of P2O5? P2O5 is the dehydrating agent, removes water. So that means when you are mixing a phosphoric acid and phosphorus pentoxide, it will give you PPA. PPA is a it's called a thick liquid. Okay, maybe I think you are going to use in a laboratory, more particularly when you are doing a third semester practical examination, practical experiments. So this is the structure of a polyphosphoric acid. So N times. So this will be repeated N times, and right side you will have one phosphoric acid group. Of course, left side also one phosphoric acid group. And this is P double bond O. This can be written as P plus O minus. Even this can be written as P plus O minus. Even this can be written as P plus O minus. That will be the another canonical form of polyphosphoric acid. So overall, polyphosphoric acid means it's nothing but a combination of phosphoric acid and phosphorus pentoxide. So it is also prepared by the combination of phosphoric acid H3PO4 and P2O5. And more particularly, this is prepared as and when it is required. So PPA finds extensive use in various chemical reactions. The more important of which is cyclodehydration. I think you are aware about dehydration. What is cyclodehydration? So dehydration means removal of water. Cyclodehydration means there also removal of water, but there will be a formation of cyclic compounds. That is the advantage. Overall, this PPA can be used as a dehydrating agent, more particularly cyclodehydrating agent in the synthesis of many organic compounds. And one more thing, this is more effective where the reagents, for example, if we are using sulfuric acid as a co-reagent, this PPA is very much effective. Hydrofluoric acid, if you are using, that's also a very much reactive. So overall, what I need to mention here, the PPA is more effective in presence of sulfuric acid, in presence of hydrogen chloride, in presence of aluminum chloride. Okay, that's what you need to remember. So with this, let's look into the application of PPA. PPA means polyphosphoric acid. I will go to the next one. Okay, so here I'm taking molecule. Just look into this. So what is the product you can observe? This is a anthracene, and of course here one benzene, here one benzene, dibenzo anthracene. So more particularly, what you can observe, this is a carboxylic acid. This also a carboxylic acid. This also a carboxylic. How many carboxylic acid is there? 6 numbers is there. That means hexa-carboxylic acid. So hexa-carboxylic acid is cyclized. Hexa-carboxylic acid is cyclized with oleum. What is oleum? So oleum is nothing but a combination of sulfuric acid and sulfur trioxide. More particularly, 30% sulfur trioxide and 70% sulfuric acid is called oleum. So what is the role of oleum? So it's only act as a dehydrating agent, removal of water. How the removal of water occurs? So I'm taking here 1H, okay, 1H from this ring, OH from this carboxylic acid group. So removal of water, and this is forms a ring, okay. This is one ring is formed, and here 1H from here and OH will go out and forming a ring here. So this is a cyclized product is obtained. So this cyclized product, when it is treated with PPA, PPA means H3PO4 in presence of phosphorus pentoxide, so giving rise to a compound called a cyclic compound which contains keto acid. This is a keto and this is the acid. And obtained one when it is subjected to reduction. So what is reduction? Reduction is nothing but a conversion of ketone into alcohol. And then decarboxylation. Decarboxylation means removal of carboxylic acid. So carboxylic acid will go out, converting into a hydrocarbon. This carboxylic acid also will go out, converting as a hydrocarbon. And dehydration. Dehydration means alcohol gets converted into double bond. Means removal of water. So you will get a dibenzo. This is one benzo. This is another benzo. Dibenzo caronene. This particular compound 1, 2, 3, 4, 5, 6, 7. 7-membered benzene fused ring is called caronene. And these two are the dibenzo. Dibenzo caronene is the name of this product. So here what you need to remember, that sulfuric acid, it will act as a dehydrating agent, thereby forms a 2 rings, here one ring, here in one ring. And PPA is nothing but a H3PO4 and P2O5. So this also, what is its role? This role also dehydrating. So OH and H will go out, H and OH will go out, forming a ketone. So the obtained keto acid subjected to reduction. Reduction means CO is converted into alcohol. This CO also converted into alcohol. This CO also converted into alcohol. This CO also converted into alcohol on reduction. And then decarboxylation. Decarboxylation means COOH is converted into H. So carbon dioxide is going, hydrocarbon is obtained, carbon dioxide is going out, H is forming a bond here, and the hydroxy compound undergoes dehydration, removal of water. So giving rise to aromatic compound, more particularly conjugation you can observe. Okay, so this conjugation, I think if there is a more number of conjugation, there will be a visible light. Okay, that is the application. So lambda max absorbance will be more. Difference between this and this will have more absorbance. Okay, when you are taking a sample and doing it in a UV spectroscopy. Okay, this is about what is called as how the role of PPA in the cyclodehydration. So with this, I will take up one more moiety. So you know that X may be NH2 or OH or sulfur. Means X may be a thiol or X may be a hydroxy group, X may be a amino group. And so when diamino compound or hydroxyamino compound or mercapto amino compound, when it is treated with carboxylic acid, so the role of PPA is to remove water. And what is the product to obtain? The product may be a benz-imidazole, the product may be a benz-oxazole, the product may be a benz-thiazole. So suppose here sulfur means benz-thiazole. Suppose here X is equal to oxygen means benz-oxazole. Suppose X is equal to nitrogen means benz-imidazole. What it means? It means that with the application of PPA, one can synthesize or prepare benz-imidazole or benz-oxazole or benz-thiazole. So here I am taking one more compound, this pyrimidine. A substituted pyrimidine. Pyrimidine, what is pyrimidine? 2 nitrogen in a 6-membered ring is called pyrimidine. A substituted pyrimidine, more particularly diamino. This is a benzamide. Okay, this is phenyl group. No, that is the reason benzamide. So what will happen? So what is the role of PPA? It removes water. How it will remove? H2 and O will go out. There will be a double bond formation between this nitrogen and this carbon. So what is the product obtained? Purine. Purine can be synthesized or prepared or manufactured starting from pyrimidine by using PPA. PPA is a polyphosphoric acid. So what is the role of PPA? It only removes water. How it removes? H2 and O is going out. So this is about one more application of PPA in the preparation of small molecules, more particularly heterocyclic molecules such as purine, such as benzoxazole, benzimidazole, benzethiazole. I will take up one more application of PPA. So what you can observe, it's I think what is the name of ether? I think you are aware about ether, no? So without this group, you can consider as 1. Okay, without this OCH3 is called anisole. ANISOLE, anisole. Anisole is also called as methoxybenzene. And this dimethoxybenzene, 1,2 dimethoxybenzene. So what is the name of this compound? 1, 2 methoxy. Okay. You need to start numbering from this carboxylic end because this will be 1, 2, 3. 3 methoxy, 4 hydroxy benzoic acid is the name of this compound. So what is the PPA role? So PPA role just to remove the water, OH and H from this position. So that is how a ketone is obtained. Okay. Similarly, anisole, when it is subjected to acetylation, what is the name of this compound? Acetic anhydride. Acetic anhydride, it will act as a source of acetyl group. What is the acetyl group? CH3CO group is called acetyl group. What is the product? So it's nothing but a electrophilic substitution reaction, more particularly acylation. Okay, this is the electrophile, this is the catalyst. Okay, and there will be a new bond formation between this carbon and this CO. So acetyl, okay, methoxyacetophenone is the product. And similarly, suppose if we are treating a what is called as phenol and cyclohexanol. You know that the role of PPA is to remove water, OH and H from the ortho position, OH and H from the para position. So two products are formed. You know that this group, cyclohexyl group, is bulky group. So bulky group occupying a ortho position to the hydroxy, because of steric hindrance, this product formation is less, whereas this product is more because bulky group is away from the hydroxy group. So overall, with the PPA, it is possible to get cyclodehydration. It will act as a dehydrating agent. More particularly, it is very much useful in cyclodehydration. So that is how a dibenzocarinone is obtained. It is also useful in the preparation of fused heterocyclic ring such as purines, benzimidazole, benzoxazole, benzthiazole, and it is also useful in the preparation of aromatic ketone and also useful in the acetylation of anisole. It is also useful in the preparation of cyclohexyl phenols, more particularly paracyclohexyl phenol. Okay, this is about the application of PPA. Okay, now tell me, is there any doubt up to this? Hello?